if you look at the graph here, this is the parent function y equals 2 to the x power, okay? I know that it has a base of 2 because notice here, when you start exponential functions, I'm always going to start at 0, 1 because anything to the 0 power is 1. But notice here, I go up 2 because 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8, and it'll stretch, and it'll exponentially grow by a factor of 2, so it's doubling each time. So the domain of this, and we'll use interval notation, is from negative infinity to positive infinity. It goes left forever, it goes right forever. Yes, the range, however, the range will be from 0 exclusively to positive infinity. Now, if you see here, notice that there is an asymptote right here. An asymptote is a line that the graph never touches. So the reason that the 0 doesn't have a bracket is because I can never touch 0. So it's from 0 exclusively to positive infinity. State the horizontal asymptote. So since what I just highlighted in orange is horizontal, the horizontal asymptote is y equals 0. It defaults at 0. There's no transformations here. There is no left, right, up, or down, but yes. State the x-intercept. The x-intercept, where it hits the x-axis. Does it hit the x-axis? It does not hit the x-axis. Therefore, the answer is in A. There is none because it doesn't hit the x-axis. So in order for it to be an x-intercept, it has to hit the x-axis. Does it have a y-intercept? Yes, because it actually hits the y-intercept at 0, 1, which is going to be our special point for exponential functions. Now, it says to sketch the line y equals x and reflect this graph over. Let me get a completely different color. Let's do pink. So y equals x is where you have the point 1, 1, 2, 2, 3, 3. So you can draw it all the way through the graph this way. I'm going to come back down through the graph, and this is where we graph the inverses, where I'm going to take x and y, and I'm going to flip them to graph the inverse. So again, just to reiterate, the function that you see here is an exponential graph. The inverse of exponential graphs are logarithm graphs, so logarithmic graphs. So we're going to show how to get the log function from here. So if I'm looking at this, and I have the point 0, 1, if I flip the point 0, 1, it becomes 1, 0, 1, 0, leaving me over here, and I will do another color. And I'll spot it right here. So let's list some of the points off to the side so we can get them to flip them. And that was that first point that I used there. So that's the point. So we have the point 0, 1. I have the point 1, 2, 2, 4, and then 3, 8. I also have this point here, which is -1 and 0.5. So those are the original points here, and I'm going to flip each one of these points. So I'm going to take it. I'm going to go off a little bit. Take it, flip it. So this would be 0.5, -1, 1, 0, 2, 1, 4, 2, and then 8, 3. So these new points, if I take the points that I have in red, plot them. So 1, 0 is here. 2, 1 is here. 4, 2, 8, 3. You can see that the log function reflects right over that line, y equals x. And again, with inverses, you can kind of tell just by the overall shape, everything has switched. Every little aspect of the exponential function has completely flipped. I flipped the domain and range, I flipped the x and y, everything is flipping all the way across. I'm going to scoot this over. to here. And this is what we did yesterday. So we take the points, flip the points, and this is the inverse. So exponential growth graph here, logarithmic graph down here. So this is what we're going to be focused on. We're going to be doing more graphing later. Today we're just going to intro it. So now you know what it looks like. It looks like this. And now we're going to look at the different properties after we find the domain and range of this too. And I can keep it out like this. Okay, now watch this. The domain of the red function here, if you look at it, it does not go left forever. It actually stops at 0. So the domain here, and I'll write it in this color too, it is from 0 to positive infinity. I want you to notice that the domain is 0 to positive infinity, and the range for the original function was 0 positive infinity. That has swapped. What is the range? What's the range here? Does anybody have the range? The red function. Does the red function go up and down forever, or does it stop? Very good. Negative infinity to infinity. And again, we switched x and y, so those should also swap. Now notice that I don't have a horizontal asymptote anymore. I actually have a vertical asymptote. And if it's vertical, it was y equals 0. Now this is x equals 0. This has an x-intercept of 1, 0, but since it does not touch the y-axis at all, then there's actually no y-intercept. So look, every single thing from the top and the bottom have completely switched places. Where it was a y, it's now an x, and then vice versa. Left, right, middle. What do I mean by left, right, middle? Here is my logarithmic function, or my exponential function. I need to convert it into a log function. So rewrite. So there's no math involved. I'm just going to take it and completely rewrite it. Here we go. The first thing you need is log, obviously, because you need the log part of that. Left, right, middle. Left is the base, which goes at the bottom, and actually write it underneath G. It doesn't need to be beside it. It needs to be a subscript underneath G. Then draw parentheses. So left, right, which is 25, equals the middle, which is 2. Left, right, middle. Left, right, middle. So this will be 2 to the 4th equals 16. Down here, the base is e. E to the 3 equals e to the 3rd. When you're solving logs, the goal is to get it away from logs. Either put it into exponential form or to hopefully cancel the log out. So this one I have to put in exponential form. So if I put this in exponential form, which is 2 to the x equals 4, left, right, middle, now my brain can easily solve for x, because what should x be here? By converting it to exponential form, I can easily say from here that 2 squared is 4, and I can answer that. Log base 4 of 64. Okay, I need to evaluate this expression. So this actually has an answer. Okay, so what I'm going to do is, since I know it has an answer, let's just say for right now that answer is x. So all of these questions you're going to set equal to x to start off. The second that I set this equal to x, I can actually convert this from a log function to an exponential function and then solve for x. So what I'll do is I'll say, okay, 4 to the x power equals 64. 4 to the x power equals 64. And again, our brains can recognize this much easier than this. And now I'm like, oh, all I have to do is figure out what can I put in for x to get me 64. Well, it's not a 1, it's not a 2, because 4 squared is 16, but 4 to the third power is my answer to this question.